To get off planet Earth is extremely expensive. It's not something you do lightly. And part of the problem is that we have to launch against Earth's gravity well. And that is extremely expensive. It takes a lot of rockets and a lot of rocket fuel. The problem is, how do we take advantage of nature's, what I call, genetic hardware store? Well, we might actually take these. This is a photograph through a microscope of Bacillus subtilis, and it's a particular kind of bacterium that's really good at making spores. And Bacillus subtilis is really great because its spores have been shown to be stable, even orbiting the Earth for nearly 6 years. We've worked with Bacillus subtilis, some with E. coli, and programmed them to make medications. And so now you don't need to know in advance what you need. If you can take those organisms, program them, and then put them in some kind of stable cell form and send them with the astronauts can make their own drugs. And what if you thought of DNA not as coding material, but as a building material? Think, it's very skinny. It can be made very long. It's very cheap to make if it's made biologically. We're making it all the time. So what about using DNA as a building material? So then we started thinking, silver's conductive. DNA is long and very, very skinny and cheap to make. Could you now make a wire out of DNA? Turns out, you can see from that NMR, that it's 3 silver atoms that can be intercalated. Turns out thymine-thymine mismatch, you can intercalate mercury. There are all sorts of things you can do. Instead of going to a DNA synthesizer, have an organism actually make something like a wire. This is nanotechnology taking advantage of the incredible precision of life.